Take a look at this SAT math problem. We're given the equation 3x minus y equals 12, and then asked to find the value of this fraction, 8 to the power of x divided by 2 to the power of y. Right away, there's a roadblock. We have an expression with two unknown variables, x and y, but we only have one equation to work with. Mathematically, that means we don't have enough information to solve for either variable on its own. But there is a simple workaround that takes just a few minutes to learn. By manipulating the shape of the numbers themselves, we can resolve the expression without needing the values for x or y. Solving this requires a shift in focus. Instead of trying to find the variables, we will rely entirely on two foundational rules of exponents. This is a standard list of exponent rules used on many standardized tests. To resolve our specific fraction, we only need to apply two of them. The first is the power of a power rule. This tells us that when you raise a base with an exponent to another power, you multiply the exponents together. The second is the quotient rule. When you divide two identical bases, you subtract the bottom exponent from the top. We'll keep both rules pinned to the side of the screen. Looking at our target fraction, our immediate obstacle is the bases don't match. 8 on top, 2 on bottom. It might be tempting to divide them to get 4, but because they have exponents, that calculation is mathematically incorrect. To create a common base, we rewrite the 8 as a power of 2. Since 2 cubed is 8, we rewrite it as 2 to the third power. Our top term becomes 2 cubed, all raised to the power of x. To clear these parentheses, we apply our power of a power rule. We multiply the exponents together, 3 times x, giving us a numerator of 2 to the power of 3x. Now that we've established a common base of 2, the fraction is ready to be simplified. Take a look at our updated fraction. Now, both the top and bottom terms share a base of 2. Since the bases match, we can use the quotient rule from our sidebar to combine them into a single term. We move the bottom exponent, y, up and subtract it from the top exponent, 3x. This flattens the fraction into the expression 2 to the power of 3x minus y. The complex fraction has been reduced to a single base and a single exponent, allowing us to incorporate the final piece of data. Let's re-examine the first equation the problem provided, 3x minus y equals 12. Notice that the expression in our exponent, 3x minus y, is identical to the expression in that first equation. Because they are equal, we can replace the entire algebraic exponent with the whole number 12. This leaves us with the final value, 2 to the 12th power. Success didn't require us to find x or y. Instead, we manipulated the expression until its structure matched the starting equation. If we check the original multiple choice options, we see that our result matches option A exactly. Matching your bases is an effective way to bypass unknown variables on standardized tests. Look for this pattern in the future. Anytime you see a fraction with base pairs like 9 and 3 or 25 and 5, you can apply this same strategy. With our updated fraction, both terms share a base of 2. Using the quotient rule, we move the bottom exponent, y, up and subtract it from the top exponent, 3x, flattening the expression to 2 to the power of 3x minus y. The fraction is now reduced to a single base and exponent, allowing us to incorporate the final piece of data from the prompt. Let's re-examine the original equation, 3x minus y equals 12. Notice the expression in our exponent is identical. Because they're equal, we can replace the algebraic exponent with the whole number 12, leaving our final value 2 to the 12th power. Success didn't require finding x or y. Instead, we simply manipulated the expression until its structure matched the equation given to us at the start. If we check the original multiple choice options, we see that our result matches option A exactly. Matching your bases is an effective way to bypass unknown variables on standardized tests. Look for this pattern in the future. When you see a fraction with base pairs like 9 and 3, apply this exact same strategy.